Alright, welcome to my next LeetCode video where I pick a random LeetCode and solve it or attempt to solve it live after seeing it for the first time. And you can follow along and see my process rather. And then afterwards, if I can or can't solve it, we'll run through some optimal solutions afterwards and see where I went wrong and where I can learn, and maybe where you can learn and where you might be going wrong as well. Alright, let's pick another medium one like the last few videos, which have all been disasters, but let's just try again. Oh, thanks for giving me that one. Alright, 1253. Reconstruct a 2-row binary matrix. Given the following details of a matrix with n columns and 2 rows, our task is to reconstruct the matrix with upper, lower, and cosum as a 2D integer array. If there are more than one valid solutions, any of them will be accepted. If no valid solutions exist, return an empty 2D array. So let's look at the details. It's a binary matrix, which means each element is either 0 or 1. The sum of the 0th row, the upper row, is given as upper, and the sum of the elements in the lower row is given as lower. The sum of elements in the ith column is given by cosum I, where cosum is given as an integer array with length n. Our task is to reconstruct the matrix with upper, lower, and cosum. So we're not given a matrix, we're given the sum. We are given the sum of elements in the upper row. We are given the sum of elements in the lower row, and we are given the sum of elements in each column. Alright. And we have to reconstruct the matrix. We must reconstruct and return the matrix. So why don't we go into paint and say we've got, let's see, do we get given n? No, but we can find n from the length. We can find the length of the matrix from the length of cosum. Alright, so if we go here and say we've got upper equals something, lower equals something. Say we've got upper equals 3, lower equals 2. Now, if we don't think about cosum, this could be 1 and length, and n is 3, say. This could be 1, 1, 1, and 0, 1, 1, or 1, 0, 1, or 1, 1, 1, 0. So cosum changes things significantly. I think maybe if we'll do a simpler thing, we'll do 1 and 2, and cosum equals, what's something we could pick? We could have it be, well, it's never going to be 2, it's 1 or 2, isn't it? Like 1, 0, 0, 2, 1. Well, that's not possible, is it? for this one we might have 1 0 0 0 0 0 1 1, and then, well, it's not possible there. If that was, let's see, not a very good eraser. No, why would it think what I wanted to do? No. I don't like paint. It's too big. Well, we might have to start 0 1, and then it's not possible to get that one. So let's write that down before we forget. What was I saying? If the sum of all cosums is more than upper plus lower, then it's not possible. The sum of all cosums is greater than upper plus lower. That's possible. Now instantly, this is looking like a recursive problem, I think. As we could start from a base case, maybe. Oh, let's just think. Well, cosum length could be massive. So that means we have to be pretty efficient, so maybe recursive's not the best way. No, that can't be right. Cosum length. It's pretty big. Oh, I haven't even looked at any examples, that's silly. So if upper is 2 and lower is 1, cosum is 1 1 1. Yes. Okay. And upper is lower, lower is 2. Now we see that cosum, the sum of them, is 6, which is greater than upper plus lower, so it's not possible. Maybe I'm wrong. Yeah, that's 10. 2, 3, 5, 6, 7. That's 10. That's 10, so that should work. What if cosum's less than upper plus lower? No, it has to be equal. It has to be is not equal to upper plus lower. It's not possible. Empty matrix. So let's think about a very simple base case. When upper to upper lower and cosum equals, say if it was 1 1 1, that would not work. It has to be 2. If it's 2, then we end up with 1 1, and that's it. If it's 1 1, we end up with 1 0 0 1. I think maybe it can still be recursive. I'm not sure. If it's, say, 0 0 1 0 1, it'll just be 0 0. Could be that. Right. I'm trying to think. It only depends whether we put it in the first one or the second row. That really changes anything. I Then we could, I suppose, maybe, is there a greedy algorithm where for each cosum equals 1, we use whichever is larger out of upper and lower. Oops. So say if upper is 5 and lower is 3, and this has to be 8. The sum of cosums has to be 8 and length 5, at least 5. Or maybe that might be important, I don't know. The length of cosum must also be at least the minimum of upper and lower. But if this was, say, 1, 0, 1, 2, 1, 2? What's that? That is, and then one more, and that's 8. 1, 2, 3, 4, 5, 6, 7, 8. This, our process would be to set the first, set that, and that's 4. And then that's 0, obviously. And then we'll do the same. And now it's 3. And then we'll take 1 from both, because we must. And then that's 2, and that's 2. And now it doesn't matter which one we take 1 from. And so we'll just take upper by default. And now that's 1. And then we have to take them both. And now that's 0, and that's 1. And we've only got 1 left to put in there. And that is a solution. Wow, that might be a pretty good solution. I'm happy with that so far. Hopefully I'm not missing any certain cases. So I think we'll go for that one for now. So a greedy algorithm. Iterate over cosum. Or over cosum as cosum. Add a new element. Iterate over cosum as we build our result 2D array. Build each row of our result. Oh, I forgot to start the timer again, but it's been about almost 15 minutes, which is not too bad. And then iterate over cosum as we build each row. If cosum I each row I, if cosum I equals 0, set as we build each column. Set both values in row I equals 0 in result. If cosum equals 2, I equals 2, set both values in row I to equal 1 in result, and subtract 1 from upper and lower. So we have to do while. Have to have a while loop somewhere, or another base case maybe. If cosum I equals 1, find minimum of upper and lower. Set maximum. Set corresponding value over I of result to equal 1 and subtract 1 from that. Now that should work if there is a solution. And I equals cosum.size. So that makes sure our array is large enough, and we go over everything in cosum. Now, if we have to make sure. Hold on. Cosum equals 2 and upper is greater than 1 and lower is greater than 1, and then equal to and greater than 1, and here we can have or and then else no solution, I think. So we don't have to do a while loop. Because we can just iterate over cosum, and then if none of these three cases are ever true, we can quit out early and just return an empty thing. I think that's a very good algorithm so far. So the time complexity is big of the size of cosum, I think. And this is the number of elements in cosum. Space complexity big of n as well, for the same reason as doesn't matter that as the constant 2 times for the matrix, it just goes down to big of n. So let's get started on this. So if we have size t, n equals cosum dot size. So this is number of columns in the result array. And if we just have vector int result, oops, and now so we do for size ti equals 0, I is less than n, I plus plus. If cosum I equals 0, do something. Else if it equals, I guess we can just do it in that order. Else if be no. Well, yeah, which one? Yeah, that's right. Okay. Else, we just return. Hopefully that's how you return. I'm not sure if that's, or if we need to. I think that should be fine. So if cosine equals 0, then we would just do result dot push back. Hopefully that works. Push back just a row. Add row of zeros. Let me think. Push. Are we? Yeah, we're pushing back. That's correct. Else, if we do it like that, then we do push back. Now we have to find which one is the minimum and the max. Find the max of upper and lower. We'll come back to that. First, here we'll do result dot push back 1 1, and then just do upper minus minus lower minus minus. So we have to find the max of upper and lower, and then subtract. So if we do I'm trying to think, because we have to find the max and the min. No, we have to just find the max, but then we have to know if the max is the upper or the lower. We need more than just the value. I guess a way we can do that is if upper equals max upper lower, do that as, then we could just do result push back 1. I don't see why this wouldn't work. Hopefully. As far as I can tell, this should all be correct, right? Am I missing anything? Let's run it. Oh yeah. So if we get to the end, oh, of course, you have to return the result, obviously. Let's see how we go here. Not good at all. Cosum. I think I see. I've been adding rows instead of columns. So how can we? Oh no, that's not good. Wait, what? I'm confused. Uh-oh. What do we? I thought we were trying to add column by column. Uh-oh. I thought this is what we're doing. But maybe that's how it's split up. Oh no. That is right, isn't it? That's how they're doing it. That means it's 0, 0, 2, 0, 1, 1. Oh no, that's not good. So, and at the moment we're doing it wrong. We've got it as 0. Oops. 0, 1, 0. Oops. No. Surely there's a way we can turn that, we can convert this into that. But maybe there's a better way to do it up here. Not good, not what we want. Oh, there's never a 2 anyway, up there. Let me just do that. Is there a way to convert that into that? I wonder. Just the first, maybe we can save this. Convert to correct format. So we just need to iterate over that and add the first one to that and the second one to that. Iterate over rows. Oh no, I think I might have messed this up. I thought I was going so well. Size ti 0 I is less than result size I plus plus. I'm so annoyed I messed that up. Yeah, so what I've got is 1 1 0 there and 0 0 1, or it's meant to be 1 1 0 there and 0 0 1. Not happy with this. Well, there's 2 rows. And there's a max 2 there. 3 rows. No, there's a 4. I thought maybe that was something. Well, there's 3 elements in colsum. 4 there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it is. That part's correct. I guess maybe it's not doing pushback, but I think maybe we can convert it. So how do we want to do that? No, I think trying to convert it is not a good way to go. What if we Hail Mary? What if we do no, I don't know what to put. Wait, so we have 2 rows. Have 2 rows the whole time. I thought that was better, but no, it's not. Have 2 rows. Upper equals result 0. Lower equals result 1. Instead of that, do result I dot push back 0. Let's just test if this works. No, it's not I, not I, not I. Push back 0. So 1, push back 0. Maybe this could work. So if we do, so we also have to just initialize those maybe. I'm not sure. I'm not sure. Oops. Push 0. Just comment that out for now. And then we can do a similar one there, where we do it like that. Similar one there, but do it like that. Similar one there, but like that. Hail Mary again. No. I think we have to initialize the 2 rows, which I'm not sure how to do. I guess we can look that up. Oh, this one's going so well. References, containers, vector, yep. I'm not sure. Sort of when we I don't really know. Could that possibly work? Oh, it does something. That works. This one doesn't work. This one doesn't work. Oh no. So why does that one work? Oh no. So why does that do that? Is that an issue? No way. Oh my god. No way. Am I a genius? Submit that. That was about 34 minutes. No! No, no, no. 10 left. 10 left. 10 left. So 4 and 7. We'll make this a test case. 4, 7. That, and that one messes up. Now why does that mess up? I'm going to guess maybe. So what happens? We've got 4 and 7, which is 11. And what's the sum of cosine? We've got 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we could just do a check there at the start. Maybe. Yeah, I think that might be good. Check if sum of cosine doesn't equal upper plus lower. So we just do 4 times t, da di da. We do int cosine sum equals 0, cosine sum plus equals cosine I, and then at the end we do if sum doesn't equal upper plus lower, return that. Hopefully that will work. It does. Please, 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 please. This will be in like 36 minutes. I've done it! Oh, my first medium I've done in a half reasonable time. I'll put that as, oops, completed in 36 minutes. Because I didn't set the timer, but I've got my recording timer, which actually I did about maybe 40 seconds, so maybe we can do 35-30. But we've got a solution. Thank you so much, and it's a pretty good one. It beats. It's pretty quick and it's pretty memory efficient. I'm very happy with that. Very happy. There's no editorial, but I feel like this might be a pretty optimal solution. Let's just double check the time complexity. Yeah, big O of n, and space is big O of n as well. Let's look at some other solutions too. 5 lines. It's not funny. Not funny. 5 lines. I don't like. No. Efficient, not efficient. Optimal solution doesn't mean the shortest. What's like the quickest? 100. What was mine? 43. Get done. You think you're on hundreds faster? No. No, I reckon, yeah, we've got the optimal solution, definitely. Yeah, greedy. Yeah, it's a bit different. First, checking for Colson value 2 if at any point we don't have enough lower and upper. Yeah, return false. I'm not sure if that's quicker or slower than this, doing one pass through fast or continuously checking if we've got enough. I think maybe that's just a more simple way, maybe not as quick, but definitely more readable and more modular and everything changeable. I'm very happy with that. Well, thank you very much for watching this video. What a massive success. My goals are to complete medium questions in less than 30 minutes, so that was pretty close. I feel like that was not a super difficult question. Definitely easier than graph questions and link to lists and trees and stuff. But you know, we take it. We take our wins where we can get them. Hopefully this is a start. This is the start of a hot streak. Anyway, thank you for watching this video. If you liked it, do leave a like, comment any feedback you have, anything like that. Definitely subscribe for more if you want more videos like this. And all the good stuff. Yeah, thank you for watching this one. I'll catch you in the next one. Alright.